My name is Jeff Miller. I'm Vice President of Product Management and Development at General Electric for an area of the company that is responsible for our global operations and finance functions. And along with Arun, Murugan, who heads our data engineering and architecture team, we're going to kind of walk you guys through why traditional data modeling and profiling is a challenge for us in our use case, and how we've partnered with Io-Tahoe to actually apply machine learning to that problem and address some of our core needs. We don't have a huge audience, so I think we can keep it interactive. If you have questions as I'm going through, please by all means raise your hands, and I will defer them to Arun if they're hard, and I'll answer them if they're easy. So, and in addition, both Arun and I are available afterwards if there's any kind of detailed question you want to go through. So what we thought we'd do is give you a little bit of background about our use case, and also try to draw some corollaries in how that's kind of abstract in general, but also kind of the specifics behind why we do what we do and how we came to this challenge and how we're overcoming it with this approach of kind of augmented data engineering, if you would. So the first thing to understand for us is we are responsible for a data lake program, as well as a portfolio of products and capabilities that we build on top of that platform. So for us, the data lake and the data as a service is really product number one, right? It is a product in and of itself by providing strong, integrated, compliant information to our finance and operational professionals throughout the company. But it is also the platform on which we build a variety of other persona-driven products, right? So that is both bespoke homegrown applications, as well as deploying traditional BI or analytic solutions on top of the data lake platform. In addition to that, we support a relatively large data science organization, right? So more of the current climate where outcome-driven and model-specific requirements of data drive a fair amount of our requirements. And I'll talk a little bit about the approach that we've taken for reuse there as well, and why this ML-based data modeling really enables both of those or all of those workloads on top of the environment. The other thing that's kind of important to understand for us, and especially when we talk about where we're going with Io-Tahoe and solutions like it at GE, is that for us, this platform is not just an analytical, nice what-if analysis platform. It is a Sarbanes-Oxley certified core part of our financial reporting, both internal as well as prepping for substantiations and reconciliations and regulatory filings and things of that nature. So that drives a fair amount of our approach and our architectural considerations. So the first thing is, I'll start by stating the obvious, right? So when we talk about data engineering and the use of ML specifically to address some of our challenges in that space, the probably foregone conclusion you've all reached is we do still do data modeling, both physical and logical in the data lake environment. So we are not using a purely schema on read style approach, and there's a couple reasons that we have chosen to do that I'll walk you through and kind of set up as we go through this material. The first reality is we have tens of thousands of internal users in the company who use this data, right? So our finance and operating professionals, the business leaders of our organization, et cetera. And a core tenet of what we're doing in those products I mentioned earlier is to provide self-service capabilities, whether that is an auditor who supports our statutory filings being able to get an extract of certified data that they need to provide to the Chinese government or the local regulatory agencies in Europe, et cetera. They need to be able to do that in a self-service based approach. That self-service in particular, along with the desire that each of my engineering and development teams should not have to reinvent the wheel, but should be able to use a singular investment in data engineering and design to then enable products on top of the data platform, is the reason that we focus on this idea of model once, use in multiple locations. And obviously for us in the finance space, a lot of our control and compliance requirements also benefit from us only having to provide audit and substantiation for one data model use case, et cetera. So those are kind of the first three bullet points there. A little bit of background, and I'm going to dive into this in a little bit more detail because it really does set the stage for why ML. Why am I not throwing bodies at this and looking at our data engineering centers in Budapest or in Bangalore doing it with old-fashioned manual labor and data modeling, is we have to be system agnostic. Just like any data lake platform, we are bringing in a tremendous amount of information from a variety of enterprise systems, and they vary significantly in their technology, right? We have 3 different current active versions of Oracle, 2 different versions of SAP, PeopleSoft, and so on and so forth, even just within our general ledger or ERP space. On top of that, we have hundreds of instances of those sources or transactional platforms and a huge variety in their process and configuration, et cetera. So for us, the need is also to provide a single view, right? I need to know what is my total spend with a given vendor across the entire company, even if those transactions ranged and split across 50, 60, 70 different systems. So this idea of the system agnostic approach is a very significant one for us. The other thing, and I'll dive into this a little bit more, is the reality in many businesses, and specifically also in ours, is transactions occur in potentially disjointed systems, right? They're integrated in a variety of different ways, but the life cycle of events and activity that has correlation and meaning to one another doesn't always happen in the same place, in the same way, consistently, et cetera. So our desire is to build this connected ecosystem, especially in the finance realm. You can think of, I'm going to have an inventory issue that will result in a sourcing transaction that will eventually cause a receipt. It will have things like the payment that we make and the accounting that we end up doing for that. And at GE, the description that I just covered will cover 5 different systems for one of our businesses, and we have many different businesses. So reconnecting that ecosystem is essential. So when we talk about building these domain-specific models, and what I mean by that is we're going to build a sort of first normal form style approach. We're not doing full Kimball and Inman, and Arun will talk a little bit about this, but we want to stay very agile in the approach. That harmonization is our, what we call critical to quality, or our #1 requirement. We have to be able to provide consistent view of the data across the board. We're not going to talk a lot about that because it's not an area where we are today employing machine learning. If you have questions about kind of what we've experienced there, we're happy to answer them after the session. But the part we really want to dive into is where have we seen an opportunity to use new approaches and new technology to address some of the issues in this domain-based platform approach. And really the kind of core of that is with our financial data, with this very heterogeneous environment spanning different regions and regulatory agencies and systems and processes, et cetera, we also have a challenge around our master data. In some cases, like many companies, from a supplier or vendor perspective or from financial master data, we author it in a traditional master data management solution and then use and employ that within the lake. In other cases, while we're making investments in those areas, we're not finished yet, right? So we have a need to provide intelligence and analytics and outcomes in absence of having that authoritative master data. So this is another area where we are using ML and AI, predominantly through a homegrown series of solutions in terms of authoring or creating data science-driven master data in our environment. So we do things like add and enrich the data with derived UNSPSC codes for commodity information, and just as an example. We mention that just by virtue of the fact that we're looking for a variety of different ways to do things differently and to take the power of having all of our data in one cohesive data lake environment as an enabler to use things like data science or machine learning to solve the problems that we have. The third category, and the one that we're really going to walk you through, is what we internally refer to as the data thread. So I mentioned a few minutes ago an example, right? I've got an inventory need for JIT or just-in-time style manufacturing. That inventory need will result in a sourcing transaction or a demand plan, which will happen in another system. And that will then be sent to a different tool or a different process by where we actually issue the order to the vendor, and another system where we make the payment, and yet another tool where we do the accounting, right? So in the data lake, I'm bringing all of those things back together. But what has happened in the natural course of history at GE is the person who created the systematic integration between the first 2 hops in that life cycle of the transaction left the company 30 years ago, and that's a mainframe talking to Pick your flavor of database that was available 30 years ago, probably Oracle. And so from our perspective, it's difficult, obviously, to reverse engineer all of the relationships, all of the entity things that we would want to find. And they don't happen consistently. There's a huge variety in that. But being able to reconstitute that thread is essential for us for a couple different reasons. If you think about, again, our primary audience being finance and operating professionals, in order to explain the why or the causality behind key metrics or analytical insights we have, I need to be able to link back to the transactions throughout the life cycle in order to look at and analyze and explain that information. The other thing, though, is, as I mentioned, we have a relatively robust portfolio of data science solutions that the team is doing as well. So not only in terms of explaining, analyzing, and reporting the information, but in providing the most complete set of data for those data scientists to have a total feature selection available to them as they define and refine our models. And an example of that, for instance, would be that same life cycle that I just mentioned in terms of that sourcing transaction. It's essential for us to understand what is happening and coming all the way back in inventory or requisitions if I want to accurately predict GE's cash flow from a disbursements and receipts perspective over the next quarter, which is a real data science model that we've done that uses the threading that we're going to walk you through in order to build a more accurate model. So when we talk about the threading in particular, why, as I said, are we not just using old school data profiling tools, having human beings go and perform a traditional normal form style analysis, et cetera? There's really two key business drivers that have really taken us to go look at alternative solutions. The first is simply the size problem for us, right? You're all here at a data conference, so you probably have similar challenges, I would imagine. But for us, the first thing we often get is it's finance data. It really can't be that complex or that big. We're not talking about the social media fire hose or a parametric or sensor data, et cetera. Yeah, true. I don't have petabytes and petabytes and petabytes of data, but I have about a third of a petabyte of information under management for just financial data today. And as you can see, that ranges hundreds of different tools, and each tool may have dozens of different processes that result in differences within the data entities. We have 120,000 plus, and this changes every week as we add data into the environment, but distinct attributes or columns that may actually contain these relationships. To give you some perspective, when we look at, and I'll talk a little bit about one of the unique requirements we had that we've been co-innovating with Io-Tahoe on, but some of our fact entities contain 12 or 15 billion records. So when we need to discover those relationships, it's a large volume of data we need to manage and traverse through. The other thing is there's a high level of variability. So I've referred a couple times, just the differences in our processes and the amount of change that occurs. It's a tremendous amount for us to kind of wade through and analyze. So the way this actually manifests for us, what didn't work or what was it we were actually trying to solve as we looked at using solutions like Io-Tahoe in this case. The first was what we refer to as hidden or unknown relationships, right? We don't know exactly how our entities relate to one another, and there's a fair amount of untapped value or dark data that we have in this portfolio, right? Where we can actually find causality or relationships between events we weren't even aware was there, right? The other thing that we have is, the reality is, I'm trying to look at an atomic entity or event, something like an accounting entry. And I want to know how a general ledger journal relates to intercompany invoicing. I want to know what intercompany transaction caused that accounting entry, right? But the reality is I probably have no less than 150 or 200 different ways that a journal entry might relate to an intercompany invoice, even though, by the way, I only have one intercompany invoicing platform in GE. So that variability is a huge issue for us because this is not just a matter of deciding one primary key and one foreign key relationship for a transaction, if we look at it from a traditional sense. And that really boils down to the third component here, which is that within a given entity, I have many different types of events or transactions. And while each individual event or transaction carries its own variability, I have to look at each subset as its own logical entity. I have journal ledger, And I have the general ledger and journal entries, but within that, I probably have thousands of different variations of the events themselves, intercompany invoices, payable invoices, customer cash application, et cetera. And then within those subsets themselves and the difference of process or systems which they originated from. So these are some of the kind of core challenges that we had. And the reality is, Diwakar and I simply can't afford to give Arun a budget of 150 data engineers to solve this problem. So we had to come up with a different way to do that. And we'll talk a little bit about exactly how we do that and how we've been working with Io-Tahoe to actually create software and solutions that we believe are valuable not just to our problem statement, but to everybody. So with that, I'll hand it over to Arun.
Good morning. Right, so I'm Arun Murugan. I'm leading the data engineering for the finance data lake within GE Digital. I'm going to take you through how Io-Tahoe, the machine learning algorithm, is going to help us to solve the problem. But before I get into that, Jeff mentioned a lot of different things, the complexity, the magnitude, various different customizations from various different GE businesses, all the data pouring into one single centralized data lake, right? He also emphasized the need for the data modeling, right? Many of you have maybe, I wanted to ask this question, how many of you are coming from data modeling background? Oh, great, right? Majority of you understand the pain points, especially when it comes to the large data lakes. A lot of the sessions you would have attended earlier were talking about, is ETL dead? Is data modeling dead, right? But it's not dead at all in a way that it has transformed in a way to make productive outcomes for the big data lake solutions, right? So as part of the data engineering challenge, what I see is we have 86 billion transactions coming out of this 130,000 entities that we ingest from various different sources. And I have to deliver the outcome. I am under the tight deadline. If I ask my boss, who's in this room, hey, can I have 6 months to 9 months to commit for this project? Guess what? What is going to be his answer? Hell no. You're going to get it done maybe 3 weeks, maybe a month. That's all you have, right? So how do I solve this problem? I cannot definitely do it manually, given the complexity. So what we have decided is we have partnered up with Io-Tahoe, the platform which is going to help us to apply the machine learning algorithm with a co-innovation with GE team with certain techniques and methods, which is going to simplify the complex problems that we have seen or presented by Jeff earlier. So there's going to be 3 steps. Again, these are all the simplified steps. Number 1, if I throw all these entities, 130,000 entities with 86 billion transactions into my data lake and ask the Io-Tahoe tool, go find me the relationships among all these entities and attributes and give me the results back. It's doable. You need a lot of computing power. You may need additional 100 nodes or maybe 200 nodes to give that computing power to process everything and get the outcome of it, right? The relationships between the entities. Yeah, we can do that. We can throw millions of dollars into it. But even if you do that, if you end up doing that, the results that you get out of all this volume of data is not going to be easy to decipher. It's not going to be easier for us, any one of us, either whether it is an IT team or it's a functional team, to discover the relationships among such a huge volume of data is almost humanly impossible. So what we have decided to do is to prioritize. We take the entities that we know that has unknown relationships with other set of entities that come from different data sources. So we have prioritized it in a way that it is going to help us to meet our business use cases. The second step is all about identification of subset of records within the entities. It's also called categorization. What do I mean by categorization? I can give you a quick example. How many of you are aware of an entity? Let's say, let me take a simple example, a contract entity, right? If your organization is in the business of selling and buying goods, you would have a simple entity called contract. The contract could be from the purchase contract, it could be from the sales, or it could be from the services that you're providing to your clients. There are different types of contracts. They're all embedded within the same harmonized entity, right? How do you differentiate them? You need to have some sort of context, right? Whether it is a sales-oriented or purchase-oriented, or it is service-oriented. That context is going to help us to segregate the data and group them in a more meaningful manner so that we could find the relationships between multiple entities in a focused and narrowed down manner to get the results that we are anticipating, right? That is categorization. So finally, the results, the machine learning results are driven by the categorization that I talked about. And it is so important for us to go through an iterative process of machine relearning process because there's going to be a lot of noise, especially if you're dealing with a large volume of data. It is given that you're going to get a lot of noise when you get to see the results. And we call them key value pairs, just like the industry calls it key value pairs. The only difference is like the key on the left-hand side is a key, and the value on the right-hand side is also a key in our case. That's the distinction. But at the end of the day, we are trying to find the key value pairs, which is nothing but the relationships between the entities. And it has to go through the iterative process, as I mentioned, based on the human intelligence input that will narrow down the results that we are looking for.
I have a question. Okay. So you're saying that there's some kind of input into this movie. Do you guys reference like the FSLVM?
Sorry, say it again?
No, we do not.
Okay.
Yeah. So in our case, and I'll let the Io-Tahoe team answer if they're using that in other cases, but no. And in fact, for us, we want it to be as generic as possible because the amount of bespoke sources that we have that don't necessarily fit industry standard or predefined models, right? And so in our case, we don't do that today, but what Arun is talking about is the intelligence of the system being able to relearn, right, over time, the nuance of our own model. So
based on the user inputs. So this is the high level, the workflow. Which starts with obviously the data connectivity. It has the connectors to all sorts of the data sources. In our case, it's our Hadoop-based data platform. And the next step, it takes us to get the metadata out of the data lake to understand some of the predetermined relationships that exist within the data lake. And it dumps the data into sets of files before the actual step one starts to kick in. If you can relate back to what I was talking about, the prioritization, this is where it is so highly critical for us to apply this prioritization of the entities that we are going to go after. I will walk you through a quick example to show you how the prioritization process is helping us to define the use cases. The group discovery is a second point, which is sort of associated with the categorization process that I talked about earlier, which is nothing but a subset of records within the same entity. And the third one being the actual iterative process, which is applying the machine learning algorithms. And mostly, it's all driven by the classification, the regression process behind it. Io-Tahoe team has implemented various different ML algorithms to take it to the next level and produce the meaningful pairs that we are looking for, the key value pairs. So prioritization of parent-child entities. So this is what I was talking about. In this particular case, what we have taken is like the general ledger set of entities that you see on the left-hand side. You have the 4 different entities. They're all general ledger, headers, lines, things of that nature. And on your right-hand side, the intercompany transactions, which is a single entity that we are trying to make some sort of a connection. So like we know that there are a lot of unknown relationships exist, but we know for the fact that these are all the major sort of attributes and entities that get us to the other next level. And again, there are thousands and thousands of attributes behind these 4 entities and also the entities on the right. And we are dealing with about 12 billion transactions worth of data.
So just real quick before Arun moves on, to kind of reinforce the point he made, what you're really looking at there is a multi-grain fact entity and lookup elements of what is effectively a star, right? And again, the purpose here is we have an outcome. I'm trying to forecast cash settlements for intercompany transactions, so I need to understand how the things relate, right? And so I have prioritized the question that we're asking Io-Tahoe to discover in this instance.
Right. So the next step is the categorization piece. Io-Tahoe, the machine learning algorithm, produces the list of fields or columns that could be the potential candidate for us to choose for subsetting the records within the entities, right? And it is important for us to look at the results in a way that there are different factors that play a role in choosing the right category. Earlier, the example that I talked about, the contract example, right, the sales, purchase, and service, the context was the different set of entities that play a role in defining the results. But in this particular case, JE's source name that we know for sure is going to contain the necessary set of values which could narrow down the relationships between the entities that you have seen on the left-hand side and the intercompany transactions that you see on the right-hand side. So one other point that I wanted to make here is you see that ML score as one of the headers here. It varies from 42, 52, 34, etc. And you have the unique set of values that each one of these attributes contain or the columns contain, and the empty values. So these 3 combinations play a major role in choosing the best categorization before you move on to apply further regression process. And it's quite interestingly that we have chosen an attribute which is JE's source name, which does not have the highest machine learning ranking or scoring. 34 is somewhere in the middle. You have the 52 as the highest score to choose from, but we decided to choose the JE source name mainly because it contains the right set of unique values. The other cases where you have the higher machine learning rankings, for example, in this particular case, batch's name and header's name have a lot of unique values behind it. You don't want to go to higher number of values, and at the same time, you don't want to see the lower number of unique values, which may not give you the right set of, the subset of records that you're really looking for. So you have to find and choose the right categorization. This is where the the user input comes into the picture. Yes, absolutely. So you see that view details on the right-hand side, which gives you the list of unique values that attribute contains. So I would let the Io-Tahoe team to talk about it, but this is the internal IP that is applying various different methods, the data science methods, mainly the regression algorithms and classification algorithms play a major role in identifying that categorization.
Yeah, again, this is the value proposition for us. We're not doing it. I don't have to dedicate one of my data scientists to coming up with and creating a logarithm. Io-Tahoe is providing that as an internal function of the product, right? And what we've seen is, along with, as Arun shared, providing the machine matching and the extra information to identify red herrings is the value proposition of the tool for us. So in all honesty, I'll be completely candid, I don't want to know how it works. I just want to know that it works, right? That's the core that we have.
How can they verify or how can they trust them?
No, and that's an absolutely valid question, and that's actually why we're showing you the one we're showing you today, is this is a real world example, right? So I mentioned it earlier, intercompany invoicing and general ledger transactions. In our case, we did a proof of concept with Io-Tahoe before we jumped all in, right, on the product. So we confirmed they could give us the results that we were looking for, and we basically did 3 tests. Could they discover things we had manually been able to discover? Could they discover the things that have the complexities that we've shared with you, the subsetting, the variability, et cetera? And could they discover relationships that we had not yet been able to find? Those were the 3 tests that we did in testing the validity and accuracy of the machine learning logarithms. And over time, in understanding our use cases better, the Io-Tahoe team has actually improved the strength of the product, right? So the way that we did it is we trusted, but we verified by putting our own data through the system.
One more question.
Sure.
So how quickly you can compute all these scores for all the data sets?
Yeah, so again, as Arun said, we don't run it for everything, right? So we can run a given prioritized subset in a couple hours, right? And again, remember, this particular one you're looking at, that's 12.6 billion records it's running through to identify the subsets and the ML scores, and then you'll see in the next screens the actual key pair likelihood and fit ratios. So for me, 2 hours is a massive improvement over taking a data engineer and giving him 4 weeks to run through to try to discover the same thing.
So complementing this with user-defined rules along with the ML algorithms?
So,
I know that I have a prefix or a suffix or it's going to contain or not.
so,
And plus.
so again, it's not always a known factor, right? So the question is like, do we have a set of rules that is applied in addition to this machine learning algorithm to narrow down the results? Yes, and the answer is yes and no, because it all depends on, because it's not always easy to find the correlation and not even the categorization. In this particular case, we may have known J's source name has a better correlation between the data entities and the relationships. In many cases, we may not have. So that is why it is an iterative process, and if you get to see some of the options at the bottom, relearn and recalculate, is based on, it's kind of an iterative process to go through and see what makes more sense.
Yeah, but
So I'm going to guess that there'll be outliers that are happening on analysis as well.
correct.
Right.
And we'll show you the screens in a second that display some of that outlier style information.
Right. So after the successful categorization process or subset selection process, what happens is like, the tool generates the groups of key value pairs. There are multiple groups, and they're also ranked by the ML score. And as you can see, there are 711 plus or groups are created. Each group contains the key value pairs, right? So the next slide is drilling down into one of the top groups that was recommended by the tool. And when you get to see the list of attributes within the group, they are nothing but key value pairs, right? So one of the things that I want to quickly point out here is like you have a unique set of values from those 4 entities that we have chosen earlier, and you have the unique set of columns that we have chosen from the right-hand side here. And the combinations of these 2 sets of unique values produced about 1,600 results, 1,600 data pairs, I would say. And this is how we get to know that, okay, there are so many permutations and combinations, even for the most chosen or the highly ranked machine learning algorithm produced. And here's the final results. You get to see, you'll be amazed to see how these unknown attributes, by the way, the field names are attribute 1, 2, 3, and 4, and 5. Who could ever imagine that these attributes contain invoice numbers or invoice sequence numbers or the business unit code to begin with and all that stuff? So this is, amazing in the sense that you could never be able to produce this kind of relationship in an efficient, in a very timely fashion. Otherwise, it would have taken for months after months to get the functional knowledge behind it.
So to reinforce what Arun is saying, in the general ledger model itself for us, there's over 3,500 distinct attributes, even post-harmonization or normalization. So to go through and run that discovery, it's checking across 12.6 something billion records, 3,500 plus odd attributes, and the correlation to a table of roughly the same equivalency on the other side, right?
So this also support all cardinality? One,
Yes, absolutely, yeah. The question was related to the cardinality. Yes, it supports all sorts of cardinality, yeah.
One question. So when you build up this relationship between entities, are you actually scanning the actual data, or are you getting some sample from the data?
Absolutely, yes. Once we get the relationships defined, we do apply those joins. That's the threading model that Jeff talked about earlier. That is an internal to GE, what we have built on top of the results. I'm going to talk about the results and how we made use of those results into the threading model.
Yeah, I think the one thing is the relationship is not built based on metadata. The relationship is actually built based on data.
What's the impact of data quality? You only have a couple minutes. You have to do a lot of preparatory work on the data in order to maintain some answer.
So no, we don't do any data prep when we're doing the discovery. The question was asked a little bit earlier about things like prefixing and suffixing and things of that nature. The one thing that we do, as I mentioned earlier, is from a master data and lookup perspective. In some instances, we are running data science and normalization models. The output of those models are included in the perspective columns to use for joining, right? That's the value of kind of the two solutions together. So, and Arun and I will stay after to answer questions. I know the overall session, we have about 3 minutes, and we want to give you guys kind of a view of our roadmap and the other things we're working with Io-Tahoe on. But we're both available to answer questions as we kind of wrap up.
So what do we do with the results? Going back to that question, right? So we take this all, the key value pairs that are produced by this tool, and we configure those results into a metadata-driven ETL framework. That's what we call it as threading framework, the term that we have introduced to connect the unknown sets of data that comes from various different sources. And our ETL jobs have been automated in a way that it can read those configurations from those metadata tables and applying the loading process in a way that it does not require us to have a specialized ETL job to run to connect the data sets. So that is the automation that has saved us tons and tons of hours, and obviously the money associated, the cost associated to it. And what we do with the data, obviously, we have our own data science team to apply our classification on top of the data. It's purely based on the data that we have already discovered. It's based on the analytical solutions, reporting solutions that are required by the businesses.
So to give you guys a little bit of a perspective as we kind of close out. So this is one of the core use cases that we've partnered with Io-Tahoe and seen significant value, merging some of the internal IP we've done in our kind of data lake architecture, our ETL framework. But we've already started with other use cases, right? The use of and the value of profiling the data and applying machine learning and data science allows us to do things like the compliance checking and profiling, right? Why pay for two separate solutions when I'm already having this data go through a large-scale ML logarithm as well? So we've started doing that for some of the GDPR and PII-related compliance restrictions that we're under as well. Two of the things that we're partnering with the team over time is discovering the relationship's great, but we shared with you the size and variability of our problem statement. The reality is my ecosystem today is going to look very different than it will tomorrow. So we're really interested in taking this and not just using it for discovery, but monitoring iteratively over time. Has anything changed in the quality of the data or the derived relationships that we've discovered? And there is a new way the data is integrated, or it's been invalidated so that our metadata framework needs to be updated. That's one of the next steps that we're looking at taking with the team. And then ultimately moving beyond just that idea of iterative, cyclical, and frequent monitoring to actual real-time discovery and streaming and other items. That's a little bit further out, obviously, on the roadmap for us, but it's kind of the other areas that we're going through. And from a key takeaway perspective, there's three things, hopefully, that you kind of got out of our conversation here. The first is, it's not enough for us to bring the data into the environment and make it available to the users and require them to reconstitute that. Whether that is an advanced user, like my 2 PhD data science lead, or it is your average payments clerk who needs to provide this information to a regulatory agency. So the relationships in the data, as well as the relationships with the partners you choose to drive these types of solutions, are very important. The second thing is, there is no way, I can tell you because I'm the guy who gives Arun requirements for a new outcome, that he would be able to deliver this with the speed and the efficiency if we tried to do this using traditional data profiling methodologies. So we add new threads into our metadata framework every 2 weeks. And we're doing a dozen or so very significant threads that are added that improve the quality of our self-service analytics, as well as our more bespoke outcomes and other solutions. And the last thing I would say is, I'll be candid, right? When we first started with Io-Tahoe, it did not do everything we needed to. This idea of prioritization, the idea of subsection, et cetera, those were things that we worked with Io-Tahoe and the team, Rohit and Oksana, and then the rest of the organization, to get into the product. So for us, the value is also in the partnership and co-innovation, because we don't know what our problem tomorrow is going to be in this space. So I don't want a vendor, I want a partner as we work with that. And for us, that's essential as we select not just Io-Tahoe, but others like the Oracle Sparkline solution we use for OLAP that also benefits from these threaded relationships to make more valuable and meaningful cubes or star schemas, et cetera. So that's the other thing we'd add. I know there's a lot of vendors here at Strata, but I'd reinforce that if it weren't for the fact that they're there, that they listen, and that they evolve and innovate their product with us, it would not be useful. And I think that's true of any other approach that you take. So I ended up 2 minutes over. We did as good as we could to stick to time. Both Arun and I will stick around for questions if anybody has them. So thank you very much for your attendance, and hopefully it was somewhat illuminating.